Hello everyone, welcome to the Information and Network Security lecture series. This is lecture number 3 and we will cover these 3 topics in this particular session. That is categories of traditional ciphers, substitution cipher, monoalphabetic cipher, in which we will study the Caesar cipher and the keyless cipher. So we start with the categories of traditional ciphers. Now why they are called as traditional ciphers? Because they are no longer used now. So when they are not longer used, and why are we studying it? We are studying it so that we can understand the more advanced to understand the concepts of more advanced cipher techniques. We need to know the traditional cipher techniques, how they work, and what are the flaws in that techniques. So with this we divide this particular ciphers in 2 broad categories. So first is the substitution cipher, other is transposition cipher. So if you recall, in the last lecture we studied that there are 2 types of encryption technique. One is symmetric, other is asymmetric. So now whatever we are studying is actually a purely symmetric technique, in which we use the same key for encryption and same key for decryption. So we'll study this 2 in detail. First, the traditional ciphers. The first is the substitution cipher, other is the transposition cipher. Now what is the meaning of substitution cipher? Now in case of substitution cipher, we substitute one alphabet with another one. Like suppose if we have a word like hello, okay, so I can substitute H, I can substitute A. For E I can substitute any other, like I can substitute B, and so on, any other alphabet. So one alphabet is substituted in place of the other one. That is called as substitution cipher. Okay, and of course they are also divided into 2 more categories that we will study afterwards. Then we have the transposition cipher. In case of transposition cipher, we are just changing the position of the alphabets. Like suppose if we have like hello, so maybe like E comes here, okay, L comes here, okay, then we have this, then we have this, and we have this L. So this H is coming here, this E is coming here, this L is coming here, this L is coming here, this O is. So we are just changing the position of the alphabets. That is called as transposition cipher. Okay, so these are the 2 broad categories of the traditional ciphers. Now let us first study the substitution cipher in detail. Now there are 2 more categories or subcategories of the substitution cipher. The first is the monoalphabetic cipher, and second is polyalphabetic substitution cipher. Okay, what is the difference between these 2? In case of monoalphabetic cipher, we have a one-to-one relationship. What is the meaning of one-to-one relationship? Suppose if I write smile here, okay, smile sees. Suppose this is the word I want to write, smile sees. Okay, I want to encrypt this. So suppose I am for S, I am substituting P. Okay, so wherever S come, I have to write P for that. Okay, now suppose for E, I write Q. Suppose I write Q for E. So wherever E comes, I will write Q. Okay, so this is a one-to-one relationship. In case of monoalphabetic cipher, every alphabet is actually encrypted with the corresponding one. Okay, like here for S, P. So if there are 100 S in my plain text, then there are 100 P in my plain text corresponding. Okay, so wherever S comes, I will substitute P. Wherever E comes, I will substitute Q. This is just one example. We can do another way also. So this is the monoalphabetic. Now in case of polyalphabetic cipher, there is no one-to-one relationship. Like I am writing this smile sees. Okay, so for one S, I may substitute A. For another S, I may get B. For this, I may get Z or any other alphabet. Okay, so this is not a one-to-one relationship between the plain text character and the cipher text character. So it may happen that I may have 100 S in my plain text, and I may somewhere I may substitute for that S, I may substitute B, somewhere P, somewhere U, somewhere S itself. Okay, so there is no one-to-one relation, but one-to-many. Okay, so out of this 2, of course this is more stronger as compared to this one. Okay, So there are various ways to implement monoalphabetic and various ways to implement polyalphabetic. Let us see them. So we start with the monoalphabetic substitution cipher type. The first type is the Ciphers cipher. Okay, it is also called as the additive cipher. Okay. Now this, why it is called as Ciphers cipher? Because Julius Caesar used to use this particular technique to convey the message to his armies. So in this case, a very simple technique. Okay, what do we do in this particular technique? We write the, first of all we write the alphabets from A to Z. Okay, so you can, in this is a plain text alphabet A B C D F to Z. So for A we go 3 places down the line. So for A we substitute D, then B with E, C with F. So A with D, B with E, C with F, and so on. So every alphabet goes 3 down lines. Okay. So for A we have D. So what we do, we start with D, E, F, G, H, I, J, K, L, M, N, O, P, and then after Z we again repeat A, B, C. So wherever A comes in our plain text, we substitute with D. Wherever B comes, we substitute with E, and so on. Okay. So this is how it is done. Now in order to make a mathematical formula, what we do is we write, we give the numbers. Okay, so A is given 0, B is given 1, C is given 2, and we go up to 25. So because there are 26 alphabets, we are starting from 0, so the last alphabet will become 25. This is the encryption algorithm. Okay, so C, okay, C is the ciphertext alphabet equal to EKP. This K in our case, this K is the key and P is the plain text and E is the encryption formula. So we interpret this C is equal to encryption of P with K with the key. Okay, and mathematically we can write this as, how we write is, this is C is equal to P plus K mod 26. Now let us see how we get this. Okay, suppose I want to encrypt A. I want to find the ciphertext for A. Okay, so I write this ciphertext. What is the C for A? The ciphertext for A. So this P. Now P is the plain text character, that is A. A is this. So the number is actually 0. So 0 plus K. K is the key. In Ciphers cipher by default key is 3. So 0 plus 3 mod 26. Now 0 plus 3 is 3, and 3 mod 26 is 3 itself. Okay, so that 3 is actually, if we see the table, 3 is actually D. So wherever A comes, we get D. This is how we can interpret. Okay, using this, actually using this formula we can write that. Okay, now to get the plain text, so formula plain text is P is equal to C minus K mod 26. Okay, so this is also simple. So suppose I want to interpret what is D. Okay, I want to I have this ciphertext as D. I want to get the plain text. So what we do is we substitute this 3, and K key is actually 3. Okay, mod 26. So 3 minus 3 is 0. So 0 mod 26 is 0, and 0 is actually A. So this is how we get it, the plain text character. Okay, so if we are if we don't want to go by the mathematical formula, we can just see this. Like suppose I want to interpret for hello. Okay, I want to know what is the this is the plain text. So plain text is hello. What is the ciphertext? If I want to know the ciphertext, we'll just go here. So for H, sorry, this one. So for H we can see this H is equal to K. So H becomes K. And for E, this is E. E is H. Now what about L? Okay, this L is O. So this is O, this is O, and this O is R. Okay, so this is the ciphertext of hello using the Ciphers cipher. Okay, now the crypt analysis. How strong is Ciphers cipher? If we do the crypt analysis, now crypt analysis, as we know, it is the art of breaking the codes. Okay, now breaking, because we need to check our algorithm, so we need to check by using the crypt analysis. Now there are the three characteristics which are of course great problem. Okay, the first what we use is brute force attack. Okay, now using the brute force attack we can easily recover the key. Any attacker can recover the key. Okay, now what are three flaws in this case? The first one is the encryption and decryption algorithm are already known. We know this algorithm. Okay, it is an additive cipher. Okay, then the second thing is there are only 25 keys to try. Okay, so as we can see here, either we can substitute A instead of for A we can write B, for A we can write C, for A we can write D. So there are only 25 substitution, not more than that. So the size of the key is only 25. Okay, now to try this 25 key is very easy. Then the language of plain text is known and easily recognizable. So these are the flaws of we can say the Ciphers cipher or any additive cipher. Okay, now there is one more cipher technique which is a polyalphabetic type, that is called as keyless. Okay, now in case of keyless, what we do, we make a table. As we can see, for A we write P. Okay, we could have written any other alphabet. Now for B, suppose we write Z, for C we write B, and so on. I've just written up to J, we can continue up to Z. So this relationship is randomly given. Okay, it is not that, see, in the previous case what we had, instead of A we had D, then every alphabet is shifting 3 alphabets down the line. But here there is no such relationship. A may shift some line, B may shift some alphabets, so this is randomly chosen. Now this table, actually it is called as keyless because there is no key. The two parties, they must share this table. Okay, now in this case the two parties must agree on a table, okay, rather than a key. Okay, now this technique is stronger than the previous one. Why? Because we cannot actually launch, any attacker cannot launch a brute force attack, because in this case, if brute force attack means of trying all the possible combinations. In case of additive cipher or the Ciphers cipher, only 25 keys were possible, but in this case we have 26 factorial keys. Okay, so if we know that for A we have C, then we need to find out the remaining 25. Okay, so for the first alphabet we have 26 combination, for the second we have 25, for the third we have 24, and so on, and we continue up to 1. Okay, so this is actually 26 factorial. So this number, the 26 factorial, if we calculate this, it becomes 4 into 10 to 26. So this is a very huge amount. Okay, we cannot go by brute force attack, but of course other attacks are of course possible, like attacker can launch a pattern attack. Okay, so in English language, E is appearing more than other alphabets, then A is also appearing more, so the attacker actually can use the pattern attack. Okay, or the statistical attack rather, it's not that, it is statistical attack, in which we know that E is more frequently used, okay, than two alphabets, and so on. Okay, so that's all for this particular session. We discussed the substitution cipher, okay, the monoalphabetic one. In the next session we will study the polyalphabetic. So thanks for watching.